Hello participants. In this lecture, we are going to cover machine learning algorithms. So before we deep dive, we need to understand what is an algorithm. An algorithm is a step-by-step instruction which we generally follow to write a code for a machine. That's what we would have covered during the school days. So here when we talk about algorithm, we are talking about statistical algorithm. That is how to apply statistics in a step-by-step manner so that you are able to solve the problem. So with the help of algorithm, you actually build a machine learning model. So when we spoke about supervised, unsupervised and reinforcement learning methodologies, you would have realized that we are actually trying to create a model from the past data. So how do you create a model? You create a model with the help of a statistical algorithm. The algorithms are very generalized in nature. You take that generalized algorithm, you put it on a data that is needed for a particular problem statement that is specific to that context. Now this generalized algorithm along with data, the insights coming from the data because of the algorithm, you are able to create a model. So model is equal to algorithm plus data. That is, algorithm is very general, but when it is applied in a particular context of data, it becomes a machine learning model. So machine learning is a class of methods for automatically creating models from the data. And machine learning algorithms are the engines of machine learning, meaning it is the algorithms that turn a data set into a model. By applying the algorithms on the data set, you are able to derive insights, you are able to derive weightages for the equation, thereby the equation is ready, which is usually called as a model. So which kind of algorithm works best? Depends completely on the problem you are trying to solve, depending on the computing resources and also the nature of the data. So all these factors actually play a role in choosing the algorithm. So machine learning programs or algorithms are nothing but the programs that adjust themselves to perform better as they're exposed to more data. The learning part of the machine learning means that those programs change how they process data over time, which as humans change how they process data by learning. So as and when more data comes to us, we humans have this tendency to take better decisions, isn't it? That is what is called as a learning. The same way, machine learning also happens where when there is more data, the learning becomes better. The algorithm is able to fine tune the data to get better insights, which makes the model more efficient. So a machine learning algorithm is a program with a specific way to adjust its own parameters, given feedback on its previous performance, making predictions about a data set. So fine tuning the parameters, which is one of the steps in the machine learning process, that's where algorithm plus data will actually help you to get a better model. So remember we spoke about three types of machine learning, correct? Supervised, unsupervised and reinforcement. So in supervised learning, the algorithm consists of a target or outcome variable, which is to be predicted from a given set of predictors. This is how you will find the kind of algorithms that are in the supervised learning. So you have a bunch of independent variables which are available with you, and with that bunch of independent variables, you want to calculate the value of a outcome variable, which is nothing but the dependent variable. So if I say y is equal to f of x is nothing but the function of the independent variables, that is x1, x2, x3. Y is the dependent variable based on these independent variables x1, x2, x3. Using these set of variables, we generate a function that map inputs to the desired outputs. So all you are trying to do is, in the historical data, you are trying to find out the relationship between the input variables and the output variables. And based on the algorithm application, you are able to derive that relationship out, and you are able to bring in a new data, thereby you are able to calculate the output. So the training process continues until the model achieves a specific desired level of accuracy on the training data. This is supervised learning algorithm. Unsupervised learning In this algorithm, we do not have any target or outcome variable to predict or estimate. It is used for clustering population in different groups, which is widely used for segmenting customers in different groups for specific intervention. So in fact, that's the reason when we speak about unsupervised learning, the two types of unsupervised learning should come to your mind: clustering and association. Finally, in reinforcement learning, what kind of algorithms are used? You can use the algorithm to train the machine to make specific decisions. It works this way: the machine is exposed to an environment where it trains itself continuously using trial and error. And the machine learns from experience, that is the environment. From there, it gathers experience and tries to capture the best possible knowledge to make accurate business decisions. So, if you have understood the objective of each and every learning approach, you would be able to understand the kind of algorithm also, like what would be the role of the algorithm under those learning approaches. So to help you understand what are the different types of algorithms or different algorithms that are available under supervised, unsupervised and reinforcement. Under supervised, you have certain set of algorithms called as the regression algorithms, which is linear or polynomial regression. Decision tree, random forest and classification are other examples. So KNN trees, decision trees, logistic regression, naive Bayes, support vector machines are some of the examples under supervised learning approach. In unsupervised algorithm, you talk about clustering. That is, you talk about support vector, then PCA, principal component analysis, and then the k-means. So these are some of the examples of clustering algorithms. And when you talk about association, we talk about a priori, FP growth, and hidden Markov model are some of the examples that you see in unsupervised. Finally, coming to reinforcement, that is, you have the Markov decision process, which is usually followed as part of the reinforcement. So depending on what kind of output you are looking at, is it categorical or is it continuous, what kind of variables you have, and what is the expected one, based on that you also choose algorithms. I hope you have understood what algorithm is, and I hope you are able to connect the data with the algorithm to understand how the model is built. Thank you very much for your time today.